Okay, in these next few questions, we're going to be looking at applying the basic angle principles. A few things didn't come out very well in this video. That here should look like m plus 52. But the important thing that we see here is that they have the same angle marking. So if they have the same angle marking, that means that they're equal. So we can just make an equation here. 5m will be equal to m plus 52. And grouping the like terms together, subtracting m, we'd get 4m is 52. Dividing by 4, we can halve and halve again, 26 and 13. M's 13 degrees. Another thing to observe here is that these angles are equal also. So if two angles are equal in a triangle, the third angle is also equal. We also know these are equal because they are vertically opposite. Vertically opposite, which we'll use in another question later on. Okay, so question 9, I think we should see straight away we've got supplementary angles here, so this needs to add up to 180. Also here for B must add up to 180. And then we can see from the exterior angle theorem for triangle ABC, the exterior angle is D. That's going to be the sum of 80 and 40, which is 120. And if we do a quick subtraction from 180, we can see that C would be 60. All right, question 10. Same sort of idea that we used before. If we have the same angle marking here, then these angles are equal. And we can also see that the other angles have the same angle markings in both the triangle, so that those angles are equal as well. So let's make our equation. Alpha plus 30 is equal to 2 alpha minus 50. Let's subtract alpha from both sides and add 50, and alpha will be 80 degrees. Lovely. In question 11, please don't forget your degree symbol, by the way, very important for your exam marks. So in question 11, we also see the same angle markings. I'm going to tackle this one a little bit differently. We're going to use the idea of that they're all supplementary angles, so they add to 180. But let's give them a symbol. So let's call this alpha and alpha, and maybe these ones in here, beta and beta. So what we know is that when we add them all together, we get 180. So that means we get 2 lots of alpha plus 2 lots of beta is 180 degrees. And we can factorise the left-hand side. That's 2 lots of alpha plus beta. And divide both sides by 2. Alpha plus beta is 90 degrees. Now we're asked to find the measure of angle ABE. So let's follow those letters. ABE. So that's this angle here. Sorry, BAE. Whoops, my mistake. BAE, so that's this angle here. So that's alpha plus beta. And so it's 90 degrees. And we're done. Beautiful. In question 12, we've got parallel lines here. We can tell by the arrows here on the lines. And also it's given here in the notation. This means perpendicular, this bit of notation here. That's perpendicular, and that tells us that we have a 90-degree angle here. So first things first, let's use our triangle angle sum. This in here must be 50. We see this is a straight angle, so this angle here must be 100. Sorry, it has to add to 180, doesn't it? So that should be 130, my mistake. And dividing those by 2, because we see that those angles are equal, and that's given here, that these two angles are equal. Divide 130 by 2, what do we get? 65. And 65. In here, now, this is interesting because we know that these two lines are parallel, as we said before, and we also know that this is a 90-degree angle. So we also know now that this is a 90-degree angle also, because the lines are parallel and 90 degrees. We can think about that like alternate angles, how there's corresponding angles, or co-interior, lots of different ways to think about it, but that's 90 degrees. So that means that in here, this must be 50 degrees to make that 90-degree angle. So alpha, let's use our angle sum, 65 plus 50, that gives us 115. So alpha here must add up to be 65 so that it adds up to 180 degrees. By the way, when these two angles are equal, that also means that this angle is isosceles. But that's not important for the question. And that's all for this video. We'll see you in another one.